Next, let's have an example. Comparing life satisfaction among single, married, and divorced people. A sample of people filled out some demographic information and a life satisfaction survey. We have single, married, and divorced group. First, we can conduct a one-way ANOVA. Let's do this with SPSS. We have two columns in SPSS. The first one is life satisfaction scores. The second column indicates group membership. So the first 5 people labeled as 1, they belong to the single group. From person 6 to 10 labeled as 2, they belong to the married group. For the last 5 people labeled as 3, they belong to the divorced group. To conduct a one-way ANOVA, we go to Analyze. We go to Compare Means, then click on One-way ANOVA. We move the dependent variable to dependent list and the group variable to factor. We now click on OK. We can choose some descriptives such as group means. This gives us the one-way ANOVA test. Here is a group mean. This is ANOVA source table. We can use our PowerPoint to better understand these outputs. The mean for the single group is 24.8. The mean for the married group is 30.2. The mean for the divorced group is 23.8. For the ANOVA source table, the between group sum of squares for between group is 118 and 533. Degree of freedom is 2. The mean square is 59.267. The sum of squares for within group is 92.4. DF is 12. And the mean square is 7.7. The overall sum of square is 210.933. The total DF is 14. Therefore, the F test is 59.267 divided by 7.7. It is 7.697 and the p-value is 0.007, so it is significant. The ground mean is the average of x1 bar, x2 bar, and x3 bar. It is x bar overall. It is 26.27. Now we can compute the effect size for the single group. The effect size tau 1 for the single group is group mean minus ground mean. So it is 24.8 minus 26.27, which is negative 1.47. The effect size for the married group is the group mean minus ground mean. So it is 30.2 minus 26.27, which is 3.93. The effect size for the divorced group is the group mean minus ground mean, which is negative 2.47. So this is one-way ANOVA. Then we can move to regression. For regression, we do need to create the dummy code in order to indicate the membership. The x variable is 3 groups, and the y variable is life satisfaction score. How to write the design matrix for this study? First, we can write the complete design matrix. We have 4 columns because we have 3 groups. 3 plus 1 is 4. Therefore, on the very left column indicates subjects. Here we don't list all 15 subjects because that would be too big. We only list 1, 2, 3. So the first one presents the first 5 people, the second one presents the second 5 people, and the third one presents the third 5 people. Then in this design matrix, the first column presents the ground mean. The second column presents the membership for the single group. So we have 1 here, 0, 0 here. Then the next column is the group membership for the married group. Therefore, we have 1 here, 0 under A1, and 0 under A3. Finally, this last one presents the membership in the divorced group. So we have 1 under A3, 0, 0 under A1 and A2. So we know that for the single group, the membership is 1, 0, 0. For the married group, the membership is 0, 1, 0. And for the divorced group, the membership is 0, 0, 1. Now we can simplify this by get rid of the last column. Then we can get rid of the constant column and have the dummy coding. It conveys the same information. That is, for the single group, the code is 10. For the married group, the membership code is 01. And for the divorced group, the membership code is 00. That is our membership. Now we can use this membership code to enter data into SPSS. This is our data. Same thing. So the first column presents life satisfaction. The second column is called vector 1. It is the first column in the dummy coding matrix. Then vector 2 is another column in the dummy coding matrix. Therefore, for the first 5 people, they have 1, 1, 1, 1, 1 under vector 1. They have all zeros under vector 2. For person 6 to person 10, they have zeros under vector 1. They have ones under vector 2. For the third group, they have zeros in each vector. Therefore, using vector 1 and vector 2, or the 2 columns in the dummy coding matrix, we can understand the membership of each participant. Then in SPSS, we go to Analyze, Regression, Linear Regression. The dependent variable is the life satisfaction. Now we have 2 independent variables indicating their membership. So we move both independent variables to the windows here. Then we click on OK. This is regression. This is ANOVA source table, and this is coefficient. We will go back to the PowerPoint to explain this outcome. Okay. Now we have the model summary. R squared is 0.562. It tells us the amount of variance in life satisfaction that could be explained by membership. Then the ANOVA source table from the regression SS, this is SS regression, which is 118.533, and this is SS for residual, which is 92.40. Then F-test. Here I pasted the ANOVA table from our ANOVA analysis. As you can see, the between SS between is also 118, and SS within is also 92. Therefore, these two ANOVA table, one from regression, one from ANOVA, are the same thing. Now we move to the coefficients. That's for testing if two vectors significantly predicted life satisfaction. We can see first the constant is 23.8. That is when both memberships are 0, the life satisfaction mean is 23.8. Then vector 1 was not significant, while vector 2 was significant. So how to interpret this coefficient matrix or coefficient table? First, we use our old ways. We write the regression equation y hat, which is a predicted life satisfaction score, equals to a plus b1x1 plus b2x2. We will have y hat equals to 23.8 plus 1 multiply vector 1 plus 6.4 multiply vector 2. This is the dummy coding. So for dummy coding, for the single group, vector 1 is 1 and vector 2 is 0. Therefore, y scores, or the life satisfaction scores for the single group, is predicted as 23.8 plus 1 multiply 1 plus 6.4 multiply 0, which is 24.8. That is the mean for the single group. For married group, we know that vector 1 is 0, vector 2 is 1. So to predict the y scores for the married group, it is 23.8 plus 1 multiply 0 plus 6.4 multiply 1, which is 30.2. That is the mean for the married group. Then for the divorced group, we would have both vectors set as 0. This is actually the base group. To predict the divorced group, y3 equals to 23.8 plus 1 multiply 0 plus 6.4 multiply 0, which is 23.8. Therefore, this 23.8 is the mean for the divorced group. It is also the intercept right here, 23.8. When you use dummy coding, the divorced group is called 0 and 0. Therefore, the mean is the same as the constant in regression. And this regression coefficient represents a difference between the group identified by that vector and the base group. Now our base group is the divorced group. Therefore, vector 1, the regression coefficient was 1, and that is 1 above the base group, but it was not significant. What it means is that the single group is not significant differently from the divorced group in their life satisfaction. If you look at the married group, vector 2, the coefficient was 6.4 and it was significant. It means it is 6.4 higher than the divorced group. Therefore, the married group is significantly happier than the divorced group. So that is how to interpret the results based on the regression. the beauty of the regression is that from this one coefficient table, we could compare the single group with the diverse group. We could also compare the married group from the diverse group. This table tells us all this information. Now let's move to the effect coding. Remember, the effect coding is very similar to dummy coding, except we give negative ones to the third group. So the third group, the diverse group, is not coded as 0, 0, but it is actually coded as -1 and -1. The reason for the effect coding is that if you add the first column, you will have 0. If you add the second column, you will have 0 again. Therefore, this average, the three group average would be 0, 0, would be the intercept. Let me show you. Here's the SPSS. The only difference is that the group membership for the third group is changed. They were not 0 anymore, they were -1s. Same in the SPSS. So to run the regression, we go to Analyze, Regression, Linear, Y to dependent, vector 1 and vector 2 to independent. Okay. So that is the regression based on the effect coding. Let me show you this in the PowerPoint. R square is the same. Then ANOVA table is still the same. However, the coefficient table is different. Now the coefficient is 26.267. The coefficient for the vector 1 is -1.467. And the coefficient for vector 2 is 3.933. Therefore, when we write regression equation, we will have y hat equals to 26.27 minus 1.476 multiply vector 1 plus 3.933 multiply vector 2. Because we used the effect coding, for single group, they were coded 1 and 0. So the mean for the single group is 26.27 minus 1.47 multiply 1 plus 3.93 multiply 0. It is 24.8. That is the mean for the single group. The mean for the married group is 26.27 minus 1.47 multiply 0 plus 3.93 multiply 1. It is 30.2. Then the mean for the diverse group, when both vectors were set at -1, it is 26.27 minus 1.47 multiply -1 plus 3.93 multiply -1. It is 23.8. That is the mean for the diverse group. Now our base group is actually the overall ground mean, because the base group is when vector 1 equals to vector 2 equals 0. So it is 26.27 minus 0 plus 0 is still 26.27. That is our ground mean. When we use effect coding, the intercept equals to the ground mean. And the significant test for the two vectors tells us if that group, such as vector 1, the single group, is significantly different from the ground mean, or if single person is significantly happier or unhappier to the whole population. Then the B weight for vector 2, which is 3.933, tell us if the married group is significantly happier than the whole population. Therefore, B1 equals to effect size for the single group. B1 equals tau 1, which is negative 1.47, but it was not significant from the general population. B2 is the effect size for the married group. It is actually significantly higher than the general population. Here we don't have B3, we don't have that divorced group. If you want to know if divorced group is significantly from the general population, you have to code it differently. In other words, you can code the single group as -1, but you code this divorced group as 1 and 0. Then you will compare this divorced group with the general population. Therefore, for the effect coding, if you use effect coding, you will have the regression coefficients that represent a difference between the group identified by that vector and the base group, and this base group is a ground mean or the general population. That's why we need both dummy coding and the effect coding. Okay, that's about regression and ANOVA. I always found this lecture amazing because it covers how ANOVA is essentially be transferred into regression. What is the interconnection between these two important statistical methods? One, ANOVA is heavily used in experimental design, and regression is heavily used in survey design. But you can see they both belong to general linear modeling family, and they could be transferred back and forth. It's amazing. So, summarize, there is no important difference between asking whether different treatments produce significant means and asking whether means are a function of treatment. Today, we reviewed one-way ANOVA. We learned the general linear modeling family. We learned design matrix, and we used an example to explain the connections between ANOVA and regression. We differentiated the dummy coding and the effect coding. Thank you.